Hi all. Today's video we will discuss about the third sorting algorithm, that is the insertion sort. I think you hope all are waiting for my video, so let's start it. So name same as what is the insertion sort? What is the insertion sort? Why we are using the insertion sort? And where we are using the insertion sort? So that we can discuss in the first thing. What is the insertion sort? The name same as we are inserting the element from an array into the correct position. That means we are inserting, right? So that is the name is insertion sort. And here we are considering two separates, like one array is sorted and one array is unsorted. Then we are merging it into the sorted order as an inserting order. So that is the reason it is named as insertion sort. And where we can use the insertion sort is commonly used for small kind of data set. And one more thing we definitely want to know, it is an in-place algorithm because it does not require in-place algorithm means it does not require the additional memory. But some case, for example, merge sort, it require additional memory for the recursion purpose and divide and conquer. That we'll discuss in the next video. So that means the insertion sort is an in-place algorithm and it does not need any memory, and the time complexity means bigger of n square. In the worst case, if the array is fully reversely sorted, it will require bigger of n square. But the best part is the best case of time complexity means it is bigger of n. That means already sorted, it will not require extra one more looping. So that means it will like a fast algorithm, fast output we will get. That is a very important point. And where we can use means partially sorted arrays. For example, already arrays, some two or more elements or a few more elements are unsorted or misplaced in this particular array. It is a suitable algorithm. Insertion sort is the best algorithm. We will get the output in a best way. So you can think about that kind of scenarios in the real life explanation. So that time we can use the insertion sort. And yeah, so time complexity is bigger of n square. For the worst case, array is reversely sorted, and bigger of n, it is a best case, array is already sorted, it will not require the conditional check. So that is the reason bigger of n. And the space complexities, as usual, it does not require any memory space, so big of 1. So we can start how the insertion sort is working and all. I will tell you. So you can see here, this is our array. So first I will consider this an array. It is divided into two. I just divided. Okay, I am dividing into two, sorted and unsorted. And the sorted means just the first element we consider as the sorted element. So we are putting this line here, and the remaining element is unsorted, we are assuming. Then the next iteration onward, what we will do, we will check with the first array with this one, first element to the next element, so which is greater. Okay, then we will be extending the element. For example, here 8 is greater than 7. So 7, 8, that is a correct order, that is a sorted order. Then we are moving to our pointer to 5. So this is the iteration number 2. And the next iteration what we will do, the pointer will move to 5, right? Then the 5, here the check will happen. That means the swapping check will happen. 5 is checking with the 8. That means 8 is greater. So this is the not correct position. And checking with the 7. 7 also greater than 5. So what we will do, 8 will be coming to here, and 7 will be coming to here, and 5 will be coming to here. That means it is moving to the correct position. So that is the reason its name is same as the insertion sort. So you can see here 5, 7, 8, and we are moving our pointer to 5 to 2. You can see here, right? Yes. So this is the one line here, and we can move into 2. Then you can see here, then the 2 will happen here. So already this array is sorted, and this is unsorted. Okay, and the next will be this 2 is checking to 8. 8 is greater, so this is not a correct position. 8 is moving to here, and 7. 7 is not a correct position. 7 is moving to the 8 position. And 5. 5 is moving to here. So what will happen? The 2 will be placed to here. So this is the correct position. So this array will be sorted, unsorted. So the pointer will be moving to 4. The next iteration pointer moving to 4 and checking. 4 less than 8, right? So this is not a correct position. 8 is moving to here and 4 less than 7. So 7 is moving to here. 5 less than 4. 4 less than 5, then moving. But when he is checking to 2, this is not the correct one, right? 2 is less than 4. So there is a gap will be here. So the 4 is placing to here. 2, 4, 5, 7, 8. So this is the sorted array. This is the unsorted array. So this is why the insertion is working. First we consider one sorted list. Sorted means the first element of the sorted and the next remaining is unsorted. Then we comparing to the each and every element and moving to the correct position. So that is happening in the insertion sort. So I think if the array is sorted, it will not require much effort because already sorted, right? Only the condition will check, there is no swapping and all. So that means we will get the big of n. Only conditional check is needed. Big of n time is needed. So I think hope you all understand this one. So we will move on the programming side, how it work and all. Then we'll look at, then you will get the better idea. Okay? Yeah. Hi all, our code is ready for the insertion sort. Then we can know how it works and all. We need to go through each and every step and the example implementation. So that I will do. So you can start from here. That's insertion of array AR. That means array we are passing and n. So for example, here array will be this one. This is the array I am passing to here. It contains 7 a number of elements. So it will be n will be the 7. And for I in the index of range of 1 to n. You can see here it is very important, 1 to n, not 0. That means it is considering to the, it is comparing to the first element of the unsorted list. That means here, this is sorted, this index will be 0, this index will be 1. So that's why it is taking from 1 to n. Okay, that means 1 to this one it will be taken. So the range index of 1 to n, insert of array index, we are passing to this one to this function. So here we will get array we will get this one, index equal to 1 and n equal to 7. So here you can see the current value equal to, so I will write here. So the current value equal to the array index of this one. So array of 1, that means 8, and position equal to index, that means 1. So here we are checking position 1 greater than 0 and AR of position minus 1. Position equal to 1, 1 minus 1, 0. That means 7. 7 greater than 8. Okay. 7 greater than 8. No, right? So this condition is true, but this condition is false. So that means we don't want to do this thing. No need to swap because already 7 and 8 are in the sorted order. No need to swap. So that is the reason we will not do this one. But we will do array of 1 equal to 8. So our total array will be 7, 8. After this iteration, array will be 7, 8, 5, 2, 4, 6, 3. So this is our array. And this part will be sorted and this will be unsorted. Then the pointer moving to the next position. So here you can see next it will be taking us 1 is incrementing 2. That means this position is moving to this position. So it is passing to here. Current val equal to 5 and position equal to 2, right? Already moving into the next position. So position equal to 2. So the condition will be that 2 greater than 0. Absolutely. Yeah, this condition is true. And the position 5, this one, right? The minus 1. So 8 greater than 5. That condition also true. That means we need to swap. Swap means the current position equal to array of position minus 1. So we already know array of position equal to 2 equal to, that means this 8 will be moving to here equal to position of my 1. So array is moving to here and position equal to 2 minus 1, that means 1. Then again this loop will work, and after this iteration what will happen, this 5 is checking with 8 is already greater, 5 is checking with the 7 is already greater, and then there is no element, right? Then the 5 will be go through this position. So that means 5, 7, 8, 2, 4, 6, 3. So this is already sorted. This is unsorted. So the next iteration what we'll do, here already we know, right? This is already 2. The next iteration it will be 3. 3 means this is 0, 2, 3. This is the position. So it will be this position and it will be moving to here. Current value equal to 2. Okay, current value equal to 2 and position equal to 3. Then it will checking the 3 greater than 0, right? 3 greater than 0, and here you already know, right? 5 greater than 2. This condition already is true. Then it need to swap. Then swapping, after the swapping, the position is remaining. Then it check with 8. 8 also greater. Then again swapping. The 8 is moving to here. And then again it is checking to 7. So that kind of iteration will happen. After that the element like this. 2, 5, 7, 8, then 4, 6, 3. So this is the iteration happening here because it is checking with the previous element where is the correct position and moving and so on. So I will tell you one more thing. I think hope you all got this point. If the array is already sorted, so this is the condition for the array, and I will tell you, we already know big O of n square for the worst case time complexity and big O of n is the best case time complexity. So how it will work? So that definitely you want to understand. For example, our array is 1, 2, 3, 4, 5. So this is our array. So what we will do, for example, we will check here. Okay, this is a sorted array. So what we do, the position greater than first position. This position is greater than this one condition is okay, but this condition will be false. That means the position minus 1 means 1 greater than 2. This condition is false, right? So it will not execute this loop. Only condition checking will not execute this loop. So that is the one, because if this condition executes, the n will be there. But this condition will not execute, n is not there. So we don't need to bother about. And again, it will be checked. So that is the reason here we need to only n. So that is the reason big O of n is the time complexity in a sorted array. But in an unsorted array, for example, if the array is like 5, reversely sorted 4, 3, 2, 1. So what will happen? It will be checked and again each and every point need to do, right? So that is an extra burden. So in this case we will get big O of n square will be the time complexity. So I think there is one more thing I just want to understand. There is no space complexity because there is no need to hold the values, right? So that's why it is big O of 1 is the space complexity. So yeah, hope you understand this one. So in the next video we will discuss on the merges or that kind of item. It will be more complex rather than insertion sort. Yeah, I think you can understand this code and you can go through 2 or more times and you will get the logic of this.